Welcome to Danimal's House, everyone. Today we're going to take a look at my system that I've created to heat 10,000 gallons of pool water each summer for the kids to enjoy the pool on more days. Let's take a look. So this pool heater concept for me has really gone back probably 13 years or 14 years since we got our very first little 12-foot Intex pool when the kids were little. I had all kinds of people say, oh, all you need to do is put a hose on the roof and put a hose in the yard and have like a little kind of copper loop and the sun will do its work. But as I figured out over the years, it is a tall task to heat water outdoors because water naturally has a cooling effect. And when you run air by it by way of wind, you're evaporating and you're losing BTU content from that water. So to heat 10,000 gallons of water up to 85 degrees when it's only 75 air temperature is actually quite a task unless you're at high noon, where the sun is bearing down on it. So I want to talk real quick about the evolution of pool heaters, and then we'll end up with what I have right here, which is working real well for us. So the first pool heater I had was like a 2-foot by 4-foot little 2x4 thing that I took some soft copper and wound it around, and I put some tar on there and put plexiglass over the top of it. And when I didn't pump the water, that thing worked real well to heat up the water. As soon as I pumped it, it was just basically cold. It was like, throwing a garden hose on a forest fire right there. So then my next thing, I made this little concrete circle, and I put PEX tubing through it, lit a fire in the concrete circle, pumped it through. Not bad. I got 17-degree temperature rise on about 1.5 gallons per minute of water flow. Then that thing cracked up in the winter. Next model, I made like a concrete tube and a whole elaborate system with like 200 feet of copper. That thing worked pretty well. I got about a 35-degree temperature rise on 3 gallons a minute. And obviously, like the simple math, the more flow you have, the harder it is to maintain your temperature rise. But the more flow you have and higher temperature rise, the quicker you're going to heat your mass of water. So then, that one quit on me again. I left the water in there over the winter and it froze and busted all the pipes, and I had to evolve again. So basically what I've evolved, or what I learned along the way, is that you really can't be too aggressive when it comes to heating water outside. So I have 2 systems that run together, and then I've got like an add-on plus system that I use when I've got a cooler day and I know the kids are having like friends over and they want to go in the pool. And so we're going to walk you through exactly how all those work. So first of all, every pool obviously is going to have a skimmer. So I've got my skimmer and my sand filter hooked up here. And what I'm doing is, under normal circumstances, if I'm not using the pool heater, I need to have the capability to just filter water. So if I'm just in filter mode, then I'm going to just run water through the skimmer, through the sand filter, and then out whatever that outlet is called. Okay, then as an option, what I did is I teed off by way of PVC. I just teed off my line here. So then I've got the capability to do both. So this one right here, that's white, that is my going to the pool. So if I don't want to run anything for the pool heater, I will turn that blue valve off and I'll turn the white valve on. And then in this case right now, I am using the pool heater, so I have the blue one on, and then I've got the white one mostly off. So essentially what we got going here is I have this little branch with that blue valve. It is pushing water through 1-inch PEX tubing, and there's 2 of them. One of them's taking them all the way like 300 and some feet over to the burn shack down another part of our property that we're going to look at a little bit later. And then it's going through a stainless steel tube heat exchanger, and then it's bringing the heated water back up through the other PEX tubing. So we've got this 1-inch PEX tube. One of these is coming from the burn shack, and then the other one is coming from that auxiliary heat that I've got going to the basement that I'll get to in a little bit here. So essentially I've got pretty good flow here. If I pull these up and I show you, I've got quite a bit of flow coming through here. I would say that's easily 5 gallons a minute. That one was the one for the house. And then this one here, this one's probably closer to 8 or 10 gallons a minute flow. I'm using a huge pump down in the burn shack, and then this pump has the capability to move quite a bit of water. So one of the things I learned over time is if you're gonna have more capability to heat, you've got to bump up your flow, otherwise you're gonna overheat your water and melt all your pipes. So let's go take a look real quick at the burn shack, and we'll talk about how that evolved and what that looks like right now. So here we are in the burn shack. So I had 4 years worth of time here that I worked at a heating and cooling place. And what I ran into is those concrete ones that I told you I made as part of the learning process. Pretty much all those broke. And turns out the manufacturers know what they're doing when it comes to engineering behind running a wood-fired water heater. So this thing was something where a customer just wanted it out of their basement. They didn't want any money for it. They just wanted somebody, they actually paid our company to take it out of the basement. So this thing's a beast, very, very heavy. So I was able to get this thing put up on concrete, and this is a wood-fired boiler. There's probably about 50 gallons of water in the water jacket, maybe even more, maybe 75 gallons of water in the water jacket around this boiler. And then on the inside, you've got fire essentially in there, and this thing is heated up. It's running right now. Then I've got that piped out to a little chimney setup that we got outside. And then what I ran into with that, because I had that exclusively for a little while, what I ran into with that is if you didn't stoke the fire, like in the middle of the night, your fire went out, you weren't heating any water. So I like the ability to have some automatic heating. Quite honestly, you go out, you buy yourself a pool heater that runs off natural gas or propane. It's automatic. The thing, you set it and you forget it. That's obviously not the case when you're dealing with wood heat, but wood heat is free compared to natural gas or propane. So basically, I just wanted a little bit more capability to have it run when I wasn't here or if I was sleeping. So that's where this came in. So this left one, this blue one, this is a oil furnace. It's basically an oil boiler, and it runs 1.1 gallons per minute of fuel oil through there and heats. Actually, this thing heats just as well as the wood burner, but this is automatically controlled. So what I did is I ran the water. This probably holds like maybe 25 gallons. So I ran the water loop, the boiler loop, basically from the boiler here to a pump, and then it goes to a pressure tank, an air eliminator, then it goes up into the wood boiler, and then out of the wood boiler into the oil, and it just makes that boiler loop. I'm calling it a boiler loop because that boiler water never actually touches the pool water. And that's important because you can't put chlorinated water in a steel heat exchanger. In a cast iron steel heat exchanger, you'll just rust the heck out of it. So if you gotta maintain your pool properly, you're gonna have chemicals in there that are way too aggressive for natural heating and components like that. That's why in many cases it's just easier to go buy a pool heater. So anyway, this thing kind of makes that loop, and as soon as this water temperature is 185, this will shut off. And if I'm running my equipment properly, there's enough flow where even if I have a raging fire in here, I can't get over 185 as long as I got enough water flow. So I kind of have those capabilities matched so that I can't have the system destroy itself very easily. So, and then they work really well together. When the fire gets kind of low here, like where it's time to fire up, this thing compensates for it. And when that fire is going good, this thing shuts off. So essentially what we're doing here is I'll just walk you through the piping real quick, give you a quick concept, and then it should be pretty easy to understand. So like I said, we kind of have that boiler loop and a same type of tube heat exchanger as what we had in the basement. And what we're gonna do essentially is we're just pumping water through that boiler loop that goes up there, then it follows over up into the wood, then it comes out of the wood, goes into the bottom of the oil furnace, and it comes back out. This little thing is gonna shut the unit off when it senses 185 degree water, and that's about it. And then on the pool side, that red 1-inch PEX line, that's coming from up way up by the pool. So that's like a 300-foot run, a little more than 300 feet. And then I got a really big stainless steel high flow Taco pump. That thing cost me enough. That's like a really, really powerful pump that runs like 10 gallons a minute. And so that thing helps circulate the water through in addition to the pool pump. So essentially what we did is we've got these lines running from here, and it goes through a tile tube, like a 4-inch drain tile tube, and that goes in the ground. And we dug a trench with the backhoe 300 feet, and we ran the drain tile through there. And then after the drain tile was in there and covered up, then we pushed those PEX tubes through, and then we ran electrical down here from the shed that also goes in the ground through conduit, and then we just run that over. And then I got some fuel oil. When I used to work at a different heating and cooling place, a lot of times I'd get fuel oil for free. I know the fuel oil is expensive. It's like $4 a gallon now, but in certain instances there was a method for me to get a lot of that for free. I have yet to pay for a gallon of fuel oil in this thing, and I've been running it for like 3 years now. So anyway, that's a look at the outdoor part of it, and let's take a look in the basement real quick for that auxiliary side, and then we'll do some numbers and show you how well this thing works. All right, so we're downstairs. We're taking a look at the second part of this pool heater system, like the secondary loop. So essentially this is just the boiler that we have. This is not my home's primary heat. This is just the boiler that's used for the indirect water heater for domestic hot water. It's also used for in-floor heat in the basement, and then it also heats the floor in the garage. So essentially what I just did here is this is a 2-zone system with primary secondary piping. Normally you'd have 110 to 120 degree water going down to the floor because concrete can only handle about that much. But in this case, what I did is I just I'm stealing a partial part of the loop. So I just closed off my basement loop, and I made like a little extra path for the water to go through. So I close it off here and I allow it to go here. And then in the winter, when I'm not running the pool heater, I just turn those back on and turn that off. And this is just another stainless steel tube pool heat exchanger, and it's capable of handling the chlorinated water. And then I changed the temperature setting on here to go all the way up to its max setting of 186. And so, because you can run 180, 190 degree water through the pipes, that's fine. You can't run that through the PEX, but you can run that through the copper pipes. And then I just have to remember to turn that thing back down, because if I run 180 degree water in the concrete, I'm going to have busted up concrete and water leaking all over. So let's go back outside. So here we are. This is where kind of the numbers come in. I don't exactly know what the gallons per minute flow is. I'm not kind of real interested in testing that. I know you can figure out your BTU calculations by that. If you figure out temp rise and flow, that'll tell you how many BTUs of energy that I'm getting between the 3 systems. But really kind of the proof is just in the pudding here. So I've got this right here. I've got a Milwaukee temperature gun. This is telling me I have got 71.6, and then we'll see how that matches up. Okay, this says pretty much the same, 72 it says on this temperature gauge. So I've got 72 degree water going into the skimmer. So when I look at that, it's basically, it was 55 last night, kind of cold for July. And then I had to do some refilling with this pool, and that's why I'm running all these heaters today, because tonight, before the end of the night, we're going to be in this pool and it's going to be in the high 80s. And that's why I went through all the effort to try to make these pool heaters work, because you spend all the money getting a pool going, all the time work maintaining it, dollars and cents of the chemicals and all that. When it's July 16th, which is what it is right now, and you have your family home for the weekend, you'd like to be able to use what you bought and paid for. So if it's 72 degrees like it is, people aren't going in there, not me either, really. So I think this is the shorter one. This is the auxiliary one that's from in the basement. So that one, we'll see what we get here. That one is 92. So we got a 20 degree temperature differential. And I would say, just my judgment is that's probably like 6 or so gallons a minute. So that's decent. With 20 degrees, I mean, that's still quite a bit of energy. And then I'll try to get this one out of here This one is way more flow. This is easily 10 gallons a minute, maybe even more, because I've got that big stainless steel pump going, and this thing's really moving some water. And I've got 103 coming out of there. So that's, you know, a 30-degree temp rise on 10, 12 gallons a minute. That's big time. You know, that you're talking like 250, 300,000 BTUs of energy getting into that flow to make that happen. And if you remember what I was saying with my old pool heaters, I think the first one I said was 17-degree temp rise at 1.5 gallons a minute. Okay, so think about how much more that is. This is like 10 times that. And then the other one I thought what I said was maybe like 30 degrees temp rise or 40 degrees temp rise at like 3 gallons a minute. So, you know, this thing really is putting out the energy, and it really has to, because when you got the wind, you know, if let's say you got even a 10-mile-an-hour wind, you're losing energy right off the top of the pool because of the water's cooling effect. So if you're losing energy by way of 100,000 BTUs per hour just because of the wind, if it's a 70-degree day and it's breezy, you got to put that much more in just to actually maintain. You got to put in 100,000 just to maintain your temp. And then if you want to raise the temp, you got to get higher than that. So like I said, it's a tall task, but we got it figured out. If you wanted to heat your pool and not go through all the hassle, just go spend the money on a 400,000 BTU automatic pool heater. But that's not how we do it here at Danimal's house. So guys, I hope you enjoyed the video. If you like it, please click for me. Otherwise, I'll see you on the next episode. All right, so check it out. So I've been messing around with these pool heaters for all these years. I told you the stories, and here we are. It's 81 degrees. It is May 30th, May 29th, and it was 81 degrees today, and I hit a hundo. All right, here we go. 101 degrees in a pool that has over 10,000 gallons in it. Boom.